In today's lesson, we are going to be looking at appreciation and depreciation. So, appreciation is a term that refers to an increase in the value of an asset over time. So, basically, what something is worth is going to increase over time. And some examples of assets that appreciate in value include things like homes. So your house can increase in value over time, right? Your house becomes worth more, especially now when there is not as much housing as there probably could be, or more and more people look for houses. The value of is going up. We also have things like jewelry. So as some jewelry gets older, the value increases because it becomes more rare, or maybe the craftsmanship it doesn't exist anymore. So the, current items tend to be worth more. Things like art pieces tend to appreciate in value, right? When paintings or famous paintings by well-known artists, right? They increase in value over time, or if the artist passes away, or if they don't make as many art pieces, or they're very rare, then that can cause these assets to appreciate over time. Now there are plenty of other items or assets or things that can appreciate in value, or grow in value, or increase in what they're worth. Things like rare items, maybe like Pokemon cards, figurines, memorabilia, some unique items, coins, gold, like things like that, right? So there's many things that can appreciate in value. If we want to calculate the appreciation, what we can do is we can take the original value and multiply it by a percent increase. So we can basically multiply a value. If we know it's increasing in value by a certain percent, we can find that percentage, and then add that back to the original value to get the appreciated value, or basically what the future value or what the new value of our item is. There is another way we can do it. We can take the original value, multiply it by 100% plus the percent increase, right? So we're multiplying it by 100 plus something, and we do that in brackets first. So we're doing that before we multiply. So this is basically a quicker way to find the new value of something, or the increased value. And we're going to look at both methods so you'll see the difference between the two, and then you can choose whichever one you like. Depreciation, you can probably guess, depreciation refers to a decrease in the value of an asset over time. So an asset decreases in value. So some things like that might depreciate in value might include things like cars. Right? Cars tend to depreciate over time. A used car is worth less than a brand new car. Technology. So as items become outdated or new models come out, technology tends to depreciate in value. Right? You're not going to pay for an iPhone 3 the same that you would pay for an iPhone 15. Right? iPhone 15, it's newer technology, more up to date, more advanced, right, than an iPhone 3. So you're not going to pay the same amount, right? That iPhone 3 is not worth the same as it was in the past. And other things, maybe things that get used, so like furniture. Furniture is an item that depreciates in value, right? Used furniture is not worth the same as brand new furniture, right? It's been used. Again, it doesn't mean that it's not not something that you would want, or that's not something that you might choose to buy, right? But it's just saying it decreases in value from what it originally was. And again, we have similar formulas in relation to appreciation. The only difference is because this is decreasing, we are subtracting the depreciation from the original value, or we're multiplying the original value by 100% minus whatever the percent decrease is. And again, we'll look at both options, or both methods, and then you can choose whichever one you prefer. They're essentially the same thing. One just has a little bit more, a few extra steps than the others. So example one, we're looking at an appreciation example. So a house is valued at $500,000 today. The house is expected to appreciate by 2% per year. What is the value of the house after 1 year? So we're going to look at method one. That was the first example that we looked at or the first formula that was presented, right? So we had to find the appreciation. And it said that the appreciation was equal to the original multiplied by the percent. So in this case, we have 5,000 or 500,000 multiplied by 2%. But when we're multiplying by percents, we multiply by the decimal form, so 0.02. And here we get then $10,000 is the appreciation. So basically that means that our house after 1 year would increase in value by $10,000. Now to figure out what the value of the house is after 1 year, the appreciated value we take the original and we add the appreciation or add what that increase is, or 500,000 plus 10,000 equals $510,000. So essentially this is what the new value is going to be after 1 year. So that's the first method. We find what the increase is and then we add the increase to the original. If we're just looking for what the value is at the end, what we can do in method two. So method two is very similar, right? Except it's the appreciated value. So this is the second formula. Appreciated value is equal to the original multiplied by, in brackets, 100% plus the percent, we'll put an arrow, the percent increase. So here we have the original 500,000. We're multiplying it by 100% plus 2%, or 500,000 multiplied by 1 plus 0.02, 500,000 times 1.02, and this will give me $510,000. So basically takes out that one extra step of adding the appreciation to the original value, right? Because I showed some extra steps here. Realistically, you could probably skip from here to here, or depending on how you good are with mental math, you could even go from here to here. So it is just kind of one step. Now, either method is fine for these types of situations. However, once we start looking after 1 year or more than 1 year, like this example, what is the value of the house after 3 years? I would probably stick to using the method two, because it is going to be a little bit quicker and we are going to look at a faster way to do this, right? So what is the value of the house after 3 years? Well, let's just make a small little table, right? We'll look at years, we'll look at starting, and we'll look at the end, or start and the end. So each year, the start of the year, the end of the year, and we'll continue from there. So year one, we start off at $500,000. We end at, we already did this calculation, but we'll do it again. 500,000 times 1.02, which is $510,000. Year two, we're starting at $510,000, and that's going to increase by 2%. So I'm going to do the same calculation that I did before, except I'm going to do 510,000 multiplied by 0.02 to get 520,200. Year 3, I'm going to start with 520,000 or 520,200, because that's what the value was at the end of year 2. And at the end of year 3, it's going to be $520,200 multiplied by 1.02, because it's going to increase by 2%. And we get $530,000, 604. So that means, therefore, after 3 years, the house is worth $530,604. Now, we could keep doing this pattern going through if it was 10 years or 20 years or 25 years, right? At the end of like kind of like a standard mortgage, what would the value of the house be? And we want to see, okay, after 25 years, what's our house worth now? Right? But this would be kind of a long and tedious process. Is there something else that we could do to kind of speed up this process to get to the end of 3 years? And if you take a look back at the calculations we did, what did we do, or what was similar in each year? You might notice that we multiplied by 1.02 every time. So at the end of 3 years, I've multiplied by 1.02 and then multiplied by 1.02 and then multiplied by 1.02. Is there a way that I could rewrite that to make it a little bit quicker? Right? If you think about it, there is a concept that we looked at that does do that in a different way, right? So if I'm multiplying 500,000 times 1.02 and taking that answer and multiplying it by 1.02 and then taking that answer and multiplying it by 1.02, that is essentially the same thing as doing 500,000 multiplied by 1.02 to the power of 3, or 3 times. Because if I did 500,000 times 1.02, get my answer, then multiply by 1.02, get my answer, and then multiply by 1.02, that is the same thing as multiplying by 1.02 cubed. So I can actually shorten this by using exponents. So this would become 530,604. So again, either way, right, we can go through and find the value after 3 years. There's a quicker way or there's a longer way, right? Both are fine. Just in terms of quickness, we probably want to use the shorter way using exponents. Example 2. So example 2, the value of a car is $25,000 today. The car is expected to depreciate by 10% per year. What is the value of the car after 1 year? Well, method 1, we want to go through just to look at both depreciation. So we figure out, we take the original and we multiply it by the percent. So $25,000 multiplied by 10%, or 0.10, and we get 2,500. We now figure out the depreciated value. So what is the value after the depreciation? We take the original and we subtract the depreciation, because we're losing the value. We're losing that value. So 25,000 minus 2,500, and we get 22,500. So that's one way that we can do it, right? Again, a little bit more tedious if we had to do then the next year and so on, a little bit harder. but not impossible. It depends on how you like to think through the question. Method 2 is doing it a little bit quicker. So we have our depreciated value, and it's going to equal the original multiplied by 100% minus the depreciation percent, or I'm just going to do percent with a downward arrow just to save myself some room. So 25,000 multiplied by 100% minus 10%, or 25,000 times 90%, which is just 25,000 times 0.90. So you might be able to just jump from the beginning down to here, depending on what your mental math is like. Or maybe you write out the percentages as decimals right away. However you do it is fine, or it's up to you. But you should be getting to 25,000 times 0.9. And when we do that, we get 22,500. So the same thing as method 1. Now the way this works is by essentially saying if I'm losing 10% of my value, essentially what the new value is 90% of the original. So we're finding 90% of what the original value was, and that would be our new depreciated value. Because if we're losing 10%, then it's going to be worth 90% of what it was. Or you could think of we're subtracting 10% and 90% remains. So example 2, the same thing with the car. The value was $25,000, and it's expected to depreciate by 10% per year. Right now, we're just going to look at the value of the car after 5 years. Now we could go through and do the table, right? Year 1. So look at the years, the start, the end. Right? We could go through and do all of that. Do at least 1 year so we get an idea how it works. So year 1 is 25,000. The end would be 25,000 times 0.90, which gave us the 22,500. Year 2, we would start at 22,500. The end would be 22,500 times 0.90 if you want. Basically figure out what is 90% of 22,500. We get 2,000 or 20,250. Year 3, we would do 20,250, and then at the end 20,250 times 0.90 equals, right? And we could continue this pattern and do it for year 4 and then finally year 5. Right? Quicker way, which we mentioned in the last example, is I can take my original value, the 25,000. I'm going to multiply it by whatever that percent change is, or whatever that new value is going to be, essentially, but what the percent is. So essentially, we are having 90% of the original value. So I'm going to multiply it by 0.90 to the power of 5, because it's going to happen over 5 years. So basically does all of this calculations for us. 25,000 times 0.9 to the power of 5. We get a value of 14,762.25. So therefore, the car is worth 14,762.25 after 5 years. Right. So you can use the table if you want, but again, it just becomes tedious in a lot of calculations. It's easier to recognize that essentially we are multiplying by zero point 0.9 or 0.9 5 times, starting with the original value. So we can use exponents to kind of speed up the process. The main thing from this lesson is just understanding what appreciation and depreciation means, how it relates to the value of an item or an asset, and can we calculate what the new value would be or determine the new value after the appreciation or depreciation.